everyone, it's Justin again. In our last lesson, we learned about evaluating functions algebraically and graphically, continuing our deep dive into how functions describe relationships between inputs and outputs. And to start things off today, we've got a quick review problem. Imagine you've been given two functions, f of x equals x plus 5 and g of x equals 3x. If we're asked to find g of 2, what exactly are we being asked? It's asking us to evaluate the function g with 2 as the input. So then what would g of 2 be equal to? Well, to evaluate a function means to substitute our input into the function to determine the output. So g of 2 results in 3 times 2, giving us an output of 6. So we find that g of 2 equals 6, which means that if we input 2, the output is 6. Nice. Now, here's a twist. What if we were presented with this task? Pause the video here and take a moment to think about how we might read this aloud and what we're being asked to do here. Well, let's see. If we read this as g of 2, then we can read this as f of g of 2. Notice how g of 2 is nested within f? This means that one function is inside the other. It reminds me of the nested parentheses we worked with in the order of operations. Like this problem. We start by solving the innermost parentheses, and then we work our way outward. So with f of g of 2, our innermost parentheses are asking us to first evaluate g of 2, which earlier we found was 6. We work our way outward, and we're now trying to find f of g of 2. And since g of 2 is equal to 6, I can replace or substitute 6 for g of 2, just like how we substitute values for variables, leaving us with f of 6, which, when evaluated using the function f, leaves us with what? (11). Because when 6 is inputted into function f, we have 6 plus 5, which gives us 11. Therefore, f of g of 2 is equal to 11. Do you see how we had one function to evaluate nested inside another function we had to evaluate? These nested functions are what we call a composite function, where the output of one function becomes the input of another. So from our previous problem of f of g of 2, first, using the function g, we input 2 to get an output of 6, which then was input into function f to get a final output of 11. This is a multi-step process where the output of one function becomes the input of another. Let's practice evaluating composite functions algebraically with an example problem. If we let r of x equal x squared plus 1 and t of x equal 2x, let's try to find t of r of 3 algebraically. Pause the video here and evaluate the composite function on your own first in your PDF. So similar to nested parentheses in the order of operations, I want to work on the innermost nested function to evaluate and then work my way outward. So in this case, I'll first evaluate r of 3 and then use the output of that to evaluate t of r of 3. All right, let's start with evaluating r of 3. After using function r, substituting in 3 for x, and simplifying, we find that r of 3 equals 10. That output of 10 now becomes the input for the next function to evaluate, which means that t of r of 3 is the same thing as t of 10. And after using function t, substituting in 10 for x and simplifying, we find that our final output is 20. So t of r of 3 is equal to 20. But what if we change this problem around and instead of t of r of 3, we were asked to find r of t of 3? Now, before we get into this problem, I want to show you another notation of composite functions. Another way to write this example problem would be like this. And this notation is read and understood the exact same way. R of t of 3. Notice that open circle. It's not a multiplication sign. It's a symbol that we use in composite function notation. Pause the video here and try working this one out on your own first in your PDF. All right, let's start with evaluating t of 3. After using function t, substituting in 3 for x, and simplifying, we find that t of 3 equals 6. That output of 6 now becomes the input for the next function to evaluate, which means that r of t of 3 is the same thing as r of 6. After using function r, substituting in 6 for x, and simplifying, we find that our final output is 37. So r of t of 3 is equal to 37. As you can see, paying close attention to the order of how the composite function is written definitely matters. If you're feeling pretty confident in evaluating algebraic expressions algebraically, I want to give you a little bonus coin challenge. Pause the video here and complete the bonus coin challenge number 1 in your guided notes. And if you don't feel ready for it just yet, you can always come back to it after more practice. All right, check it out and I'll see you back here to finish our lesson. Welcome back. Did you get c of a of t of 4 equals 92 for your answer to the bonus? Be sure to show your work and be able to explain how you got that answer so your trusted adult can reward you bonus gold. And if you weren't quite ready to try the bonus, feel free to just jot the answer down now so you know what your goal is when you work through it yourself. Now let's take what we know and move into evaluating composite functions graphically. This graph contains functions g and h. In the last lesson, we learned how to evaluate a function graphically by using the given value of the input and finding its corresponding output on the graph. I want you to take that knowledge and combine it with what you now know about composite functions and see if you can evaluate g of h of 4 graphically. Pause the video here and give it a try in your PDF. Take your time, look back at your notes if you need to, and remember, it's okay if you make a mistake, because we're going to go over it together once you give it a go first. Just like before, we want to evaluate the innermost function first and then work our way outward. So here, we'll find h of 4 first, and then use that output to find g of h of 4. Okay, let's get started with finding h of 4. If we input 4, on the graph, we find that the output for function h is 5. So h of 4 is 5. Next, we're going to work on g of h of 4. We can use our output for h of 4 to rewrite this as g of 5. And if we input 5 on the graph, we find that the output for function g is -1. So g of 5 is -1, which means that g of h of 4 is -1. Well done. Let's practice this one more time with an example problem. Use the graphs of functions below to evaluate m of n of 5 graphically. Pause the video here and give it a go in your PDF. Okay, let's see. I evaluate the innermost function first and work my way outward. So I'll start with n of 5, and then use that output to find m of n of 5. To evaluate n of 5, I input 5 on my graph, and find that the output for function n is negative 2. So n of 5 is negative 2. Next, I evaluate m of n of 5, and I can use the output for n of 5 to rewrite this as m of negative 2. And if I input negative 2 on my graph, I find that the output for function m is 4. So m of negative 2 is 4, which means that m of n of 5 is 4. Nice work. Bonus coin challenge time again. If you feel up for it, pause the video here and complete the bonus coin challenge number 2 in your guided notes, and we'll see you back here when you're done. Did you get that d of O of g of negative 2 equals negative 4 for the answer to the bonus? Again, don't forget to show your work and be able to explain how you got that answer to get that bonus gold. Composite functions are interesting because they allow us to combine multiple functions together to produce more complex relationships. They're like little function puzzles. And in today's lesson, we learned how to evaluate a composite function algebraically and graphically, both of which really have the same multi-step process. Evaluate the output of one function, and then use that as the input for another function. We start with the innermost problem and work our way outward. After finishing up this video and the guided notes, head on over to your additional practice in your PDF. It'll prepare you for the practice game. And if you weren't able to finish those bonus coin challenge problems, give them another go after the practice game. You already have the correct answers to these bonuses jotted down, so be sure that you can show the correct work for them and explain how to get to them. That's what's worth some bonus gold. Great work today, and I'll see you next time.